The question number 11 says that a body is executing simple harmonic motion with the amplitude of x naught. Its angular frequency is given omega. At some position on its path, its potential energy is equal to kinetic energy, the velocity particle at that instant. Now, dear student, kinetic energy and potential energy are equal, and at any position, the potential energy is this one and kinetic is 1 by 2k a square minus x square, where a I am taking amplitude. Therefore, in that case, x comes to be a by root 2. This is the location. Now, in our case, what is a given equal to x naught is given. So we'll replace in future a to x naught. And see, the velocity at that point is equal to omega a square minus x square root. So I'll fill here omega a square minus a by root 2 square root, that is equal to omega, and this become a square by 2 root. This is equal to omega a by root 2. That is the velocity at that time. And what is a? A was equal to x naught. And see the option, the third option is omega x naught by root 2. So the correct option to this is option number 3. The question number 12 is, coin is placed on a horizontal platform which undergoes vertical oscillation harmonically with the angular frequency of omega. The amplitude of oscillation is gradually increased. The coin will leave the contact with the platform. Now what happens? This is some platform and the coin is placed on this platform. So it is taking vertical oscillation. And see, at the extreme point, it has the maximum acceleration. At this point and this point. But see, when it is here, the acceleration is in the downward direction. And when it is here, the acceleration is upward direction. And what do you find? When it is at this point, in that case, its weight can become 0. Or this acceleration should not exceed the gravity. Otherwise, it will get detached. Now, nothing happened at this point. So, the chances of leaving the platform is at the highest point. In between, the acceleration is less. It's a falling. But in this case, acceleration is up. Therefore, so the chances to leave the contact is at the highest point of the platform. So answer to this is 3. The question number 13 is, if the amplitude of oscillation of simple pendulum is increased by 20%, then percentage change in its maximum kinetic energy. See, the maximum kinetic energy in SHM is equal to 1 by 2 m omega square a square. So that means the maximum kinetic energy is proportional to amplitude square. I says that this amplitude is increased by 20%. So this is equal to a plus 20% of this value. That is equal to 1.2a. Therefore, the new kinetic energy is proportional to 1.2a square. So if I divide the new kinetic energy to old kinetic energy, this is equal to 1.2 square. This was one value and this here 2 value. So k new to the k old is equal to 1.44. So what do you get? That k prime is equal to 1.44, the initial kinetic energy. And what is changed? Delta k by k into 100, and that is equal to 1.44k minus divided by the initial value, that is k, multiplied by 100, and you get this is equal to 44. So the percentage change is 44% increase in the kinetic energy. Therefore, the true option is the fourth one. Let's look at the question number 14. A mass m is suspended from a spring with force constant k. It just touches another spring of spring constant 3k fixed to the floor as shown in the figure. When the mass is put into small oscillation, the time period of small oscillation is. Now dear student, when it is here in contact, so it is pushing down the lower spring also, then in that case the effective, this become a parallel arrangement. So k effective become equal to 4k. And this continues for the half of the oscillation. When it reaches at this point, this will get separated So only in the other half, only K will be effective, only this spring. So that means a half oscillation is with this spring constant and half oscillation with this spring constant. And therefore the total time is equal to half for this one and half for this one. And what is T for this one is equal to 2 pi m by k, and for this is equal to 2 pi m by k. So you can take something. This is the total time for one oscillation from here to here. So that is equal to, so 2 cancel with 2 and 2 cancel with 2. So 2 can be taken out. So 1 by 2 into pi m by k plus pi m by k, and this become equal to 3 pi by 2 into m by k root. Now look at the option. The option number 4 is 3 pi by 2 root of m by k. Therefore, the correct option to this is option number 4. The question number 15 says, for a particle undergoing simple harmonic motion, the square of the velocity is plotted against square of the displacement, x square. The graph obtained will be, now dear student, what is the relation for velocity? That is equal to omega a square minus x square and root of this one. Now what will be square? That is equal to omega square a square minus x square. So that become minus omega square x square plus omega square a square. This is some constant, and this omega is also constant. So I write v square is equal to minus constant x square plus another constant. Now the graph is between v square, and let's take as y, and between x square as x plus certain constant. Now see, this graph will be a straight line because equation is y is minus mx plus c. So the graph is a straight line. To option 3 is the correct option.